as I said just now, please make sure that you have your handout with you, okay? Because we're going to be referring to this a lot. But I want to let you know that the slide that I'm going to use, dia mungkin akan melompat ke sini ke sana lah. Okay, but we are going to see how much we can cover in 3.1 today. Okay, so 3.1 is page 84, 85, 86, and 87. Okay, so kalau ada kamu nampak itu soalan, okay, on the PowerPoint, and it should be mengikut urutan lah, but mungkin saya tersilap. So kamu cari-cari sajalah. It's just in between these 4 pages. Okay, 84, 85, 86, and 87. Okay. Secondly, I am not going to stop to I'm not going to stop and say, okay, everyone, now you can copy. No. Okay, bila kamu nampak itu jawapan, terus cepat-cepat kamu tulis lah. So jangan, I got no time to wait for you all to copy lah. So when you see the slide, faster copy. Or if you want, you can wait until the recording comes out, and then you can slowly copy it in. Okay. So in this chapter, we're going to be looking at electricity lah. Okay, so electricity is one very important component in physics because we are talking about electrical energy. Okay, we've been talking about a lot of energy, force, different kinds of energy so far. We've talked about heat energy, we've talked about light energy, we've talked about kinetic energy, we've talked about potential energy. Okay, and so now we move on to another form of energy, which is electrical energy. Okay, and so when we talk about electrical energy, we have to first talk about this thing, two very important concepts, which is current, okay, and potential difference. Dalam bahasa Melayu, potential difference is beza keupayaan. Okay, dalam bahasa pasar-pasar, okay, it's also known as the voltage. When I say the word voltage, when I say the word potential difference, okay, you need to think about this. It is the same thing lah, voltage. Okay, potential difference. But current and potential difference are two very different things. Okay, they are totally different units. They are totally different things altogether lah. We must not say that they are the same thing. Okay, so the first picture in your module shows you this lah. Okay, shows a light bulb that is connected to a power supply. Okay, and the question is, what makes the light bulb light up? Okay, apakah yang menyebabkan filament lampu itu menyala? Okay, so when you are not connected to the battery, this thing doesn't light up. Okay, and then when you complete the circuit, okay, it lights up. Okay, so the idea that we want to get behind this is we want to know, astaga, we want to know, oh no. Okay, we want to know what exactly it is that makes the light bulb light up. Why do our fans function? Why do our lights function when we turn on the switch? Okay, that's the idea we want to we want to study about in this chapter. Okay, so before we do that, okay, I want to talk to you about this thing called a Venn diagram generator. Ini actually kan, tiada sudah dalam kamu punya sukatan, but saya mau kasih tunjuk juga lah. Okay, I'm not sure if you've seen a Venn diagram generator before, but this is a Venn diagram generator, and what it does is it generates charge. Okay, dia menjana cas. Okay, it generates charge, and when you hold on to the dome, okay, sini adalah dome. When you hold on to the dome of the Venn diagram, you find that wow, kita punya rambut boleh naik ini. Okay, there's a very famous Mr. Bean comedy lah about this Venn diagram generator. Okay, but this is a small scale one yang kebiasaannya ada di makmal, tapi macam makmal sekolah kita tiada. Okay, this is a huge Venn diagram generator. Okay, but the main point of the Venn diagram generator, okay, is that it generates charge. Okay, and so, oh sorry, is this a video? Oh no, hold on. Oh, okay, it is a video. And so one of the ways that we can see whether charge is flowing, okay, is we have this thing called the plasma ball. Okay, so the thing in the center here is where the charge is flowing, and then the charge is flowing and it touches at the side over here. Okay, actually this plasma ball you can buy from quite a lot of places. I'm not sure whether Mr. DIY sells, but I think Mr. DIY does sell. Okay, plasma ball. Yeah, it's quite fun, when you put your hands on it, then see, look, when you put your hands on it kan, the charge flows towards where the hand is. Okay. Yeah, so it's pretty interesting lah. Okay, so this is a gambaran on how we can see the charge flow. It's called a plasma ball lah. Kalau dia adalah charge yang biasa bahkan we cannot see the charge flow lah. Okay, but there is a certain chemical inside that causes us to be able to see, you know, this charge flow. But actually dia punya charge itu is not very high lah. Or actually it's a little bit safe. We can touch it lah tanpa kita rasa terenjat lah. Okay, look at the lady's hand she's like, okay, I'm Wonder Woman or something like that lah. Okay, so yeah, okay. So this is a video to show you the Van de Graaff generator. Okay, so this guy is put inside a cage, okay. And so there is this, yeah, so the generator is generating a huge amount of charge, okay, and it's flowing towards the nearest electrical source, sorry, the nearest metallic source lah. Okay, but this guy is safe. So the question is, why is this guy safe? Okay, yeah, see, he's totally safe lah. It's not like, oh no, he's not being electrocuted. So apa yang sebenarnya menyebabkan dia kan terlindung daripada this very high voltage lah. We will say this is a very high voltage. Okay, there's a lot of current flowing. Okay, and it's going towards this metal thing because this is the nearest tempat yang paling dekat kepada the source of the charge. Okay, so so look, the guy is still alive, yay! Okay, although it's called the cage of death, but he didn't die lah. Okay, he's still living. Okay, this is also the same reason why whenever it's raining and kalau kita ada apa guntur kan itu, it's called guntur lah. Yeah, whenever we have lightning kan, we don't stand in an open field because of the way electricity works lah. Okay, electricity must find the nearest, you know, the nearest source so that it can continue to flow. And so if you're standing in an open field, you are the highest point in that field. Kalau there's nothing else around you, you are the highest point in the field. So naturally, all the charge will come towards you first. And that's why people can get electrocuted. So lain kali, tolong jangan main hujan, especially kalau ada guntur. Okay, especially if there's lightning, be very, very careful. Don't play around with lightning, okay? Okay, so this is another one. If you remember the picture that you saw just now, we are expecting this. Is this a guy or a girl? Okay, anyway, we're expecting this person, the hair, to stand up lah. Okay. Okay, so this person is putting his hand there. Not yet turn on lah, belum turn on lagi. Tapi bila dia turn on, okay, look at the hair. Okay, wow, shake the hair. Wow. Okay. Now, why does this happen? It's because the charge that is being generated here is flowing all the way until the end of the hair. Okay? Yeah, it's flowing all the way. So the charge that is flowing all the way to the hair will make the hair stand up. Sebab all the charge that is flowing is the same charge. And the same charge dia akan menolak. Okay, just like if you have a positive and positive charge, and this one we will study in a little while. Okay, if we have two positive charges, okay, they will repel. Okay, mereka akan menolak antara satu sama lain because they're not attracted to one another. If you have a positive charge and a negative charge, okay, they will be attracted to one another. Okay, and so the reason why all this hair is standing up is because the charge that flow is the same charge. Okay, it's the same, probably all positive lah. Okay, or probably all negative. And so that's why the hair, dia bukan sahaja berdiri tetapi dia berasingan. Okay, the hair is like kind of separated lah. Okay, this is a cool look to have lah. But unfortunately, it doesn't work on me lah, for obvious reasons. So anyway, yeah. Tapi kalau kamu yang rambut panjang ni boleh cubalah. Okay, but I also must say lah, I've tried this before. Sorry, not me lah. But I have a few students who tried this before kan yang tidak berjaya because diorang punya rambut terlampau tebal. Yeah, sometimes if your hair is too thick also, it's a little bit hard for it to flow up lah. So mau rambut-rambut yang nipis-nipis yang senang betul untuk dia naik. Straight hair that is usually very thin is easier to see lah. If you have very thick hair or if you have very curly hair lah yang paling susah. Okay, boleh juga tapi sangat weird looking lah. Okay, I cannot imagine kalau curly hair yang naik. Okay, but yeah, one day if you have a chance to go and see a Van de Graaff generator, kan just put your hand on it. You won't die one, don't worry. Okay, it's just that your hair all will stand up lah kalau kau punya rambut tidak terlalu tebal. Okay, so let's talk about electric field. What is an electric field? Okay, this is the first box in your design. So an electric field is a region where a charge, okay, where charges experience electric force. Now there are two types of charges. Okay, there's a positive charge and a negative charge. So an electric field is a region around the charge that mengalami daya elektrik, that experiences an electric force. Okay, I want you to also copy down this gambar aja lah. Okay, take note of all the arrows. Okay, note that the positive arrow, the positive charge, all the arrows are always going outwards. There is no arrow that is going inwards for positive charge. Okay, manakala the negative charge, all the arrows are always going inwards. And that's why when you put both the positive and the negative charge together, they will attract one another. Because ini keluar, ini masuk. Ini keluar, ini masuk. Ini keluar, ini masuk. So the electric force will give them a force of attraction. Okay? Yeah, force of attraction. Okay? So there are two types of forces lah. When we talk about electric force, there are two types of forces. One is the force of attraction. Okay, and then the second one is the opposite. Daya tarikan, attraction is tarikan, and then the opposite is the force of repulsion. Okay, repulsion is daya tolakkan. So daya tarikan, okay, or attractive force, attraction force, let me change color, okay, is it happens when you have different charges. Oh my goodness, sorry. Different charges. Okay, charge yang berlainan. Satu charge positif, satu charge negatif. Okay, whereas repulsion force, a charge experiences a repulsion force when you have the same charge. Okay, for example, if you have a positive and a positive, okay, dua-dua positif kan dia punya anak panah adalah keluar, kan? And that's why they will experience a repulsion force because they cannot be attracted to one another. Okay, so the first thing we need to understand is this lah. An electric field, medan elektrik adalah satu kawasan di mana a charge experiences an electric force. Every charge has an electric field. Okay, either the electric field is going out, which is a positive charge, or the charge is going in, okay, which is a negative charge. Okay, and if two different charges meet together, they will experience a force of attraction. Manakala, if two same charges meet together, they will experience a repulsion force, repulsive force lah, or repulsion force also boleh. Okay, can so far?
Okay, sir.
Okay, just yeah, if I go too fast, sorry, if I already move to the next slide and then sir, belum, okay, then you faster tell me lah. Otherwise, saya hanya akan bercakap sampai jam 3. Okay, alright. So you have this thing, okay, the electric fields by using an electric field kit. Actually, we have this in our lab, but I tell you, kita punya MCO kan. Macam ibarat kamu 2 tahun bersama saya kan, kita hanya belajar di online saja ini kan. I wonder how many percentage of our class is online and how many percentage of our class is actually offline. Kan? It's okay. Okay, kita reda saja. Okay, dan kita doakan supaya SPM kamu berjaya. Amin. Okay, so you have two plain electrodes connected to the terminals of an EHT power supply. Now, EHT power supply, okay, so I want to talk about this EHT lah. EHT stands for extra high tension. Okay, dalam bahasa Melayu dia adalah VLT ya. VLT is voltan lampau tinggi. Okay, and when we talk about extra high tension, okay, when we talk about extra high tension or voltan lampau tinggi kan, we are talking about at least lah, okay, at least 5,000 volts, okay, or 5 kilovolts lah, okay. So this is very high voltage. Okay, so when you have this thing, okay, so these are electrodes. So one side is positive, one side is negative over here. Okay, and then these two electrodes, dua papan besi ini, okay, dia dimasukkan ke dalam satu cecair, okay, yang ada semolina grains, okay. Semolina grains is biji benih rumput, okay, biji benih rumput on the surface of the castor oil. Okay, and we will see a certain observation lah. Okay, so I wish we can do this because it's kind of fun to see, but let me show you how it's like. Okay, so this is okay, so the voltage lampau tinggi is here. Okay, so over here they are going to high voltage supply. This is the negative, this is the positive, this is a petri dish. They're going to pour in minyak lah. Okay, this is oil lah. Okay, and then after that, okay, so now he's going to taburkan the biji lah. Sorry, yeah, the semolina grains. Okay, yeah, semolina grains, biji benih rumput lah. Okay, so when it turns on, okay, so he's setting it. This is about 2,000 to 3,000 kilovolts lah. It's pretty high lah actually. Okay, I'm not sure if you can see, but you can see that actually the grains are moving. Okay, dia sedang bergerakkan, dia sedang bergerak lah. Okay, so now he's going to increase the voltage, and when you increase the voltage, you can see, yeah, the bijian actually bergerak even more lah. Okay. Yeah, actually, I'm not really sure if you can see. Yeah, he's increasing the voltage even more now at 6,000 volts. Okay, so you can actually see that, yeah, you can see that they are moving lah, but the problem is there's a reflection kan, tidak nampak. Sorry, okay, okay. So just now was just two dots. Okay, now he's going to put the plate, just like the one that we saw just now lah. Sorry, in this one, two plates. Situation A and situation C. Okay, sorry, situation A, two plates. Okay, so there are two flat like that lah. Okay, so when you turn on, you see that the grains are actually moving. Okay, so negative to positive is over here. If you pour in more, you can actually see the grains moving lah. Okay, yeah, don't worry, I will send this video to you. Yeah, he's zooming in now, but yeah. So you can see that actually the grains are moving, okay, and they are moving because they're experiencing an electric force. Okay, this is the negative terminal, as I said, this is the positive terminal. And after a while, they form a certain pattern. Okay, they form a certain pattern after they stop moving lah. Okay, and you find that if it's two plates, it is forming dia macam garis beginilah. Okay, to show the medan electric, okay, the electric field. Okay, once they stop moving like this, you see that actually it is a line, one line here, and then another line here lah. Okay, saya tidak tahu lah apa yang biji-biji buat di atas sini lah, but Okay, now you can see lah. Okay, it's even a little bit more obvious now. It's actually moving from, okay. Okay, I think that's about it. Oh, he's gonna tabo some more biji lah. But basically, that's kind of the shape that we want to see lah. Okay, the movement so the point of this is to show this lah. Okay, the pergerakan biji itu shows that there is an electric force. Okay, and electric force is experienced in an electric field. Okay, so this is how it will be like lah. This first one okay, this first one, if it is a single charge, okay, it will look like this. All the electric field will be going out like this. Okay, sorry. So if you want to draw, from here kan, you just draw like outside like this lah. Okay, usually I will draw 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like this, like 8 directions. Okay, to show all the 8 directions. But the most important thing is this: positive charges, the direction of the force is outwards. Okay, manakala negative direction is inwards. Okay, so you make sure that you draw the arrows inwards. Doesn't have to be dotted line. If you want to draw it a straight line also can, as long as you make sure you draw the arrow in the correct direction. Okay, and so if you have 2 plates like this is what you will get. Okay, you will get yang di atas itu a slightly curved, and then over here is straight lah, from 1 positive to 1 negative, 1 positive to 1 negative. Okay, this luar sini adalah slightly curved. Okay, from 1 positive to 1 negative. Okay, then in this force situation, 1 bar which is negative and 1 dot which is positive. Now remember, positive selalu keluar. Okay, so this is what we will. Oh no, why did I skip this? Okay, fine. Okay, so the positive one will go up like this. Okay, from the dot to this one. Now, 1 positive, 1 negative, when they meet each other, okay, they will form a very nice line, okay, joining all in. But remember that the negative always has all these other lines going in, and the positive always has all these other lines going out. Tetapi kalau dua negatif yang bersama-sama, oh sorry, the F1 yeah, sorry, can you change the F1 to negative and negative? Actually, if we change to positive and positive, also is the same pattern. There will be this ruang in the center that is totally tiada. Okay, this is where the repulsion force is lah. Okay, but if we change it to negative, negative, you can draw the same line, but it's always going inwards. Kalau kamu mau kekalkan positif positif di dalam gambar raja itu, you draw the same line also lah. Okay, except that it is going outwards, macam ni. Okay, I give you some time to draw this first. Just tell me when you're done, but don't take too long lah. Okay. Okay, so sorry this question and the question inside here there is like a little bit all over the place lah. So this, okay, question number 1 okay, the pattern formed by the semolina grains is actually your question number 6. Okay, can you see the question? Okay, so yes, I'm going to go according to this. Okay, you just find the question and then you write the answer at the appropriate place lah. Okay, sorry for the mix-up. So an electric field is represented by a series of arrow lines called an electric field line of force. Okay, what does the line indicate? It indicates the magnitude of the electric field. Okay, question number 2, the electric field lines, sorry, question number 2, but yours is question number 7 now. Okay, electric field lines of force never cross over. Okay, take a look at this. Dia tidak bersilang. Okay, dia tiada persilangan, it will be always separated. Okay, so describe the direction of electric field lines of the force in the activity. Okay, the electric field lines always move from positive keluar, to negative. Okay, it always moves from positive to negative. And that's why That's how we know lah. Okay, whether a certain charge is a positive charge or negative charge. Positif selalu keluar, negatif selalu masuk. Kalau dia bergerak dari positif ke negatif, means it's going to attract one another. Right? Moving on. Okay, how is the strength of an electric field indicated with field lines? Okay, question number 8. Okay, your question number 8 now. Okay, so the electric field is strongest. Okay, if, sorry, this is if. Sorry, okay, this is if. Okay, electric field is the strongest if the electric lines of force are close together. Kalau dia punya garis sangat rapat, okay, like this, like this, like this, like this, like this, right? Okay, then the electric field is strong. Tapi kalau dia berjauhan like this, okay, then you will say that the electric field is weak. Okay, I wish I can show you the semolina experiment lah. Actually, it's quite fun to watch. You can see that if you kasih kurangkan the voltage kan, then the lines will be far apart. But when you increase the voltage, the semolina lines will be very, very near to one. Okay. All right. Question number 4, which is your question number 4. Why do we use cooking oil and why don't we use water? Okay, because cooking oil is not a good conductor. If we use water, and guys, remember this is 5,000 volts. Okay, 5,000 to 6,000 volts lah. So we don't use water because water is a very good conductor. Takut nanti kamu yang kena renjatan elektrik. Okay, so we use cooking oil because cooking oil is not a good conductor. Okay, now question number 5. Yours is question number 1. Okay. Sorry dia sangat terbalik lah. Okay. Maaf zahir dan batin. Okay, so why do we use EHT? Okay, why do we use extra high tension? Okay, because we want to get a strong electric field. Kalau kita setakat pakai bateri biasa yang 1.5 volt bahkan, jangan haraplah kamu nampak apa-apa. Because the field is too weak. Okay, we want to be able to see the pergerakan of the biji semolina. Okay, so we have to use a strong field. That's why we use a EHT. Okay, why do we use metal plate? This is question number 5. Is it question number 5? Question number 5. Okay, why do we use metal plate? Because it's a good conductor. Okay, so that the semolina grains dia boleh pergi ke the other side lah. Are you guys okay?
Okay, sir.
All right. Okay, let's move on. Okay, bahagian ini is actually in your notes is electric field strength, but unfortunately I don't have the English version for this lah. Okay, so I'm going to write down this. I'm going to write down the English words, the things that I feel are important that you write down in your notes. Okay, so kekuatan medan elektrik is called electric field strength, EFS, electric field strength. Okay, so let's assume that there is a positive charge, okay, that you put inside an electric field. Okay, so this is the electric field and then you put inside a positive charge Q over here. Okay, it is going to experience a repulsion force. Okay, because it's the same charge. Okay, whereas if the electric field is a negative field, it's going to experience a attraction force. Okay, daya tarikan. Okay, don't copy anything yet. Okay, so this charge, okay, dia akan mengalami satu daya elektrik. It's going to experience an electric force. And as I said just now, there are 2 types of electric forces. There's either the attraction force or the repulsion force, depending on whether it is the same charge or different charge. Okay, so the electric field strength, okay, this is actually in your textbook. Sorry, I don't have my textbook with me, so I have to, this one I copy from the textbook. So the electric field strength, you can copy this in your box if you want. Okay, is defined as the electric force that acts on a unit charge positive. Okay, can somebody tell me what it says in the textbook? Sorry, I don't know. What is the textbook in this one? What does it say in the textbook? Can you tell me the page in the textbook that says this one? Electric
Page
field and
95.
Okay, thank you. Page 95. Okay, so what you can do is you can copy down the definition and the formula and the meaning of this one. But the formula is actually E equals to F over Q. The electric field strength, okay, is the electric force divided by the quantity of electric charge. Okay, now since it is an electric force, and just like all forces, okay, all force, the unit is Newton. Okay, but the thing that is new, okay, is the quantity of electric charge. The quantity of electric charge, okay, is the unit for it is C. C for this guy's name called Coulomb. Okay, Coulomb is Coulomb, not Coulomb. Okay, yeah, I know. I have a lot of students that say Newton Coulomb. It's not Coulomb, okay, it's Coulomb. Okay, so Newton per Coulomb, okay, is the strength of the electric field. So very easy. All you have to do is just know what is the value of the electrical force, and you also have to know what is the quantity of electrical charge. Okay, usually it's given to you lah. Okay, do you want some time to copy or can I move on?
Move je lah, sir.
Let me see. Yeah, this next one is also actually inside a textbook. Is this also page 95?
Yeah.
Okay, page 95. Okay, the same thing lah. Okay, the electric field charge that is produced by two plates. Just now was two charges, two dots. Okay, two dots there, we count like this. But if it is two plates, we have to count this way. Okay, V is the potential difference, okay, the voltage. Okay, you can also say voltage lah, walaupun dalam buku dia cakap potential difference. Okay, and then D is the distance between the two plates lari. Okay, and you can actually tell me lah, what is the relationship between E and V? And what is the relationship between E and D? Can anybody tell me? What is the relationship between E and V?
Directly proportional.
Okay, they are directly proportional. The bigger the voltage, the bigger the electrical field strength. Okay, and what about D? The distance between these two plates? How is the relationship like?
Inversely proportional.
Oh dear. Yeah, okay, inversely proportional. I was already going, actually, I was already going to say, yes, you're correct. Thank you, Dora, for helping me. Okay, it's inversely proportional because the bigger the D, okay, the further away the distance between these two plates, okay, the electrical field strength is going to be much less. Okay, but the difference between these two formulas, okay, is that this formula melibatkan two, dia tidak melibatkan plate. It melibatkan two charge. Okay, but this formula, okay, involves the plate. Okay, the voltage and then the distance between the two plates. So please differentiate between these two formulas. Okay, very, very important. Okay, and also at the same time, dia punya unit pun berlainan lah. This is volt per meter. Okay, because this jarak di antara dua plate selarikan, the unit must be in meter. Manakala the electrical field strength is Newton per Coulomb. Okay, so it's different lah. This is for two charges and this is for two plates. Okay, all right. Hope this is given in your this one. Okay, so hold on. Okay, let me see if I can finish these two. Okay, so we want to see the effect of electric field on two different cases. Okay, so in this first case, you have this, you have a ball over here, okay, and usually it is a ping pong ball. Okay, you have a ping pong ball in between two electrodes. One is a positive electrode, one is a negative electrode. Okay, and this ping pong ball is coated with a conducting material. Okay, dia kena cat. Okay, dia kena cat oleh satu cat yang boleh mengalirkan elektrik. Okay, it can conduct electricity lah. So like maybe silver paint or something like that. Okay, and it is put in between here. Now, when this thing turns on, we want to know what happens to this ball. Is it going to go to the left or is it going to go to the right? Because we know that if this is a conductor, dia memang akan tertarik. And it's going to be pulled to one side lah. But we want to know which side is it going to be pulled? Is it going to be pulled to the positive side or is it going to be pulled to the negative side? Okay, so at first the ball is in the middle between two metal plates. What happens when the EHT power supply is switched on? Okay, the ball is not going to be moving. It's going to be at rest actually. Interesting, right? Okay, when the ball is in the middle, it's going to be at rest, and I will explain this in a little while. Okay, so let's mark the two forces that are acting on the ping pong ball in this diagram. Okay, so since this is it's going to be like this lah. The two forces are going to be attracting it to one another. Dua-dua akan saling tertarik, and because of that, we have a situation where there is an equilibrium of forces. Because the force coming from here and the force coming from here, okay, the electricity is flowing over here lah. Okay, but the force coming from here is both the same strength. Okay, and since it is both the same strength, it is going to tarik with the same this one. That's why the ball is at rest. Okay, dia dua-dua akan tarik. Okay, both the plates, okay, are going to try to pull the ball towards them. But because they have the same strength, sebab dia orang punya sumber adalah sama. Okay, so it's going to be not moving. Okay. Can I continue? All right.
Yes,
Now,
sir.
explain the situation. Explain this situation. Why is it not moving? Okay, so. Okay, this thank God. Okay, so when you turn on the EHT supply, plate P is going to be positively charged. So here, positive, 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 because here is positive charge. Plate Q is going to be negatively charged. Okay, since the ping pong ball is neutral, okay, it remains at the center as the electric forces acting on it are equal but in opposite direction. Okay, there is an equilibrium of forces. Okay, the forces are equal lah. Okay, equilibrium of forces. Okay, dua-dua akan menarik. The positive also will try to pull, the negative also will try to pull. So in the end, the polystyrene ball is fight lah. Okay, fight to no end because it's the same strength. Okay, dia punya kekuatan adalah sama. So what to do? No choice. Okay, but that's not the end of the story. Okay, that's not the end of the story. Okay, we want to see what happens in B. Okay, let me know when you finish copying. All right. So now, what happens? Okay, take a look. Take a look at question B. Question B says that you push the ball to one side. Okay, so originally when I turn this on it's not going to move. It's going to stay in the center. But let's say saya yang kasih tolak lah. Saya kasih tolak pergi sebelah sini. Okay, the question is it going to stay on this side? Okay, adakah dia akan kekal di sebelah atau adakah dia akan pergi balik ke sebelah atau adakah dia akan kembali ke tengah? Okay, and this is what I want you to see. Astaga. Oh, sorry. Ada. Jangan khawatir. It's a very important video, so I must show. Okay. Hey. Oh, here. Okay. So we find that when we push the ping pong ball to one side, dia akan berayun tau. Okay, it's going to go back and forth, and it won't stop going back and forth. Okay, so why? Why does it go back and forth? Apa yang menyebabkan dia terus berayun? Padahal saya kasih tolak ke tepi saja. Then saya let go then dia akan berayun. Why? Why does that happen? Okay, this is when it turn off lah. Okay, so I turn off this one and it becomes like this. Okay, so when I push the ball to one side, okay, what we will find that the ball will start oscillating, okay, which is what we saw just now. Okay, so the ball is displaced so that it touches one of the metal plate. Then you let it go. Okay, lepas saya kasih sesarkan ke tepi sini kan, saya kasih lepas, and then we find that the ball will oscillate. Dia akan berhayun kembali, and it won't stop until you turn off the EHT. Okay, so the question is why? Why does that happen? Okay, this is the long one lah. Okay, so let me break it down. When the ball touches, okay, so this is the positive plate P. Okay, P is positive, positive, positive. Okay, this is Q. This is negative, 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 negative. Okay, so at first, the ball over here, it has both equal positive and negative charge. Okay, when I push it to the side, okay, when I push it to the side, it's going to receive a positive charge. And because it receives a lot of positive charge, it is going to experience a repulsive force. Sebab terlampau banyak sudah charge positif yang ada di sini. Charge positif bertambah. Okay, so you added charge positive. So too much charge positive is going to have a repulsion force going the other way. Okay, then when it comes over here, what's going to happen is all the positive charge on the ball is neutralized by the negative charge. So yang positif yang banyak-banyak ini kan, dia akan kena neutralize lah. Okay, neutral. So hilang. Okay, tetapi dia akan menerima terus negative charge. Okay, the ball receives negative charge sampai another repulsion force balik ke sini. And then balik ke sini, all the negative charge yang originally dia terima daripada sini kan akan di-neutralkan dan masuk lagi balik positif banyak. Sampai terlampau banyak positif, repulsion force lagi balik. So basically what is happening, it is just a repeated repulsion force. Okay, too much of one thing is not good lah. Okay, too much positive charge, repulse. Too much negative charge, repulse balik. And it goes back and forth. Okay, until you finally stop the EHT from flowing. Because selagi ada arus mengalir, selagi ada bekalan voltan, the negative charge will always be kena supply di sini. And the positive charge will always be supplied over here. Okay, so, but when you turn it off, after a while it will become no more lah, because there's no more positive charge to pass on over to the ball. Okay, so take some time to understand this explanation. It's a very important explanation, but it's actually very easily understood. Okay, remember the video just now lah. Okay, remember when you first turn it on, it is not going to move because it is the same force. That's why you have to push it to the side a little bit so that it receives enough positive charge. Then when you let it go, it will automatically repulse. Dia akan automatically ditolak kepada sebelah. And repulse again, automatically tolak ke sebelah, and so on and so forth. Okay. Okay, we have time for one more. I want to do this sampai the number 2 lah. Okay, yang pasal lilin itu. And then after that, we will stop for today. Let me know when you're done copying. Oh no. Okay, so your question C. Okay, question C is over here. State the relationship between the distance. Oh, no. Hold on. Okay, wait. Yours is the speed of the ball is increased when the... Okay, fine. So this one is number 3. The speed of the ball is increased when the voltage of the power supply increase. Makin banyak kau punya voltan, bahkan makin cepat dia akan menghayun lah. Okay, that's this point number 3, right? C3, correct?
Yeah.
Okay, and then this one is the relationship between the distance and the movement of the ping pong ball. Okay, so the speed of this one will be increased. Okay, the shorter the distance, the faster the ball moves. So this is C1. Okay, the speed of the ball is increased when the distance between the two metal plates is decreased. Okay, dia adalah inversely proportional. Kan? Makin dekat dia punya jarak, you will move a lot faster. Okay? What about the mass of the ball? What do you think? The speed of the ball is increased when the mass of the ball. What do you think? Increase or decrease? It's not very logical.
Decrease.
Decrease. Okay, so the mass of the ball decrease, you get the speed of the ball will be increased. Okay, one last one. Okay, one last one, and then we will call it a day. We want to talk about this candle. So, same thing. This candle on this left side, okay, left and the right side is the same thing. Is EHT. Okay, so you have a, sorry, I'm not really sure which is the positive and the negative. Okay, but we know that this is EHT, high tension. Okay, extra high tension. And when we turn on the extra high tension, okay, look at this candle and look at what happens to it. Automatic. Okay. Okay, so when we turn on this one, look at what happens to the candle. Okay. It seems to be bending more towards the right side. Notice that? Oh no. Okay, let me see if I can get a better picture. Okay, like this. It seems that more of the fire, okay, lebih banyak api yang tertarik ke sini berbanding dengan yang di sini. Sini sikit saja. Sini banyak kena tarik. Okay, sini sikit saja kena tarik. Okay, so the question is why? Why does this happen? Okay, I'm going to say that this is positive and this is negative. Okay, and I will explain why later. Why is it that the fire is more attracted to the negative side and not so attracted to the positive side? Okay, this is what we're going to talk about. Okay, so the observation, the first observation is the flame spreads out into two portions. Okay, second one, the spread of the flame towards the negative plate is bigger. Okay, like the one I showed you just now. The one towards the negative plate is bigger. So, let's take a look at this. What are the charges on plate X and plate Y? Since X is connected to positive, okay, X will be positive. And since Y is connected to negative, Y will be negative. Okay, and draw the shape of the candle flame where it displays an electric field. Now, notice just now we said that the spread of the flame towards the negative plate is bigger. More fire is going towards the negative side. Okay, so this is how it will look like. You can draw it like this if you want. Okay, more flame is going towards the negative side. Okay, so without the electric field, it is like this Kalau kau tidak kasih on bahkan, okay, dia akan neutral. But the moment you turn it on, you sambung kepada EHT, here positive, here negative, okay, you're going to get a flame that is like this. Okay, bigger towards the negative and smaller towards the positive. Okay, let me know when you're done copying. Almost done for the day. So it will look like this except that this side is negative okay, this side is positive. Dia terbalik. We know that the flame will look bigger towards the negative. Must look bigger towards the negative. So the question is why? Okay, it's not enough that we know that this is going to happen. We must also be able to understand why. Just like the ping pong ball, how come it continue to that? Okay, we must know why. Okay, so what is the effect of the candle flame on the air around the candle? Okay, so this is the number one thing you need to understand. The candle flame actually ionizes the air molecules. Okay, now by referring to the movement of the charges between the two metal plates, explain the shape of the candle. Why is it that the positive side has a bigger flame and the negative side has less flame? Okay, oh no, okay. Okay, so the heat okay, of the flame, okay, produces positive and negative ions. Okay, and oh my goodness, the ions are attracted to positive to opposite plates. Oh, okay, so I think we need to fill in your this one a lot better lah. Okay, so for D, yeah, okay, for your module, okay, for D, the what ions are attracted to the negative plates? Can you tell me which ions are attracted to the negative plates?
Positive.
Okay, positive ions are attracted to the negative plates, and the negative ions attracted to the positive plate. Okay, so the question is, explain why the candle flame is not symmetrical. Okay, it is because the positive ions are heavier. And this experiment actually proves to us that positive charges are a lot heavier, okay, than negative charges. If you remember your chemistry, negative charge is basically an electron, but positive charge is a proton, and the proton is way heavier than an electron. Okay, so this experiment proves to us that positive ions are heavier. And so disebabkan positive ions are heavier, dia akan lebih tertarik kepada yang plate negative. Okay, because they're heavier lah. They have a stronger pull compared to the electrons, which are much lighter. Okay. All right. I think that's it for today.